Automation. I'm John Stoltz. I am not really a testing guy so much, so I'm, a lot of credit goes to Yanquin and Vishal and Sumit, and special thanks to Milos and Chase for helping out, kind of putting this together. Wanted to run through some kind of a quick Rosetta slide just so that, folks, most of these should be familiar to everybody. The one that might be worth calling out in particular is the LCRs. So those are the Linaro Factory release, which is basically Linaro's fork of AOSP that we use to support particular LMG member boards. And it's sort of considered kind of a semi-stable base to demonstrate some of the features that Linaro's tried to enable. Want to talk a little bit about the current testing effort that's going on in LMG around LCR. So we've got here at the CI-linaro.org, we've got Jenkins instance that runs through kind of continually building LCR releases for a number of different boards. Those builds get sucked into Lava and go through CTS tests, benchmarks, as well as functional tests. And then that gets all aggregated to this Android QA reports, which is an internal site. And then basically every month those test results get summarized into a PDF. There's script to generate it. And that gives you kind of the CTS results, the Lava functional tests and benchmarks, as well as any open bugs that we have. And so this is useful because, a lot of work to kind of get this automation going and to provide these results every month to folks, to our members, kind of lets them know kind of where the LCR release is. But it's not without its difficulties. There's a lot of stuff that we have to kind of work around to get this out regularly. So first of all, CTS is a big issue just because it takes a really long time to run. For monthly releases, doing that summary, that's not a problem, but it's one of those things for casual testing. It's 16 to 20 hours average runtime for us. So that's kind of rough. It's also not particularly well suited for automation. We run into a lot of problems where in order to, there's not like a nice API to kind of query things. So in order to do the, after we kick off tests and get them running, to check on the status to see if errors occurred, and then collecting the results, there has to be a lot of kind of text parsing that's a little fragile in order to get that automated inside of Lava. We also have other kind of issues where since we connect, so ADB, which is the Android Debug Bridge, that wasn't an acronym in my little Rosetta slide, but normally this is the way that you're able to connect to devices and run things on them over USB, but it also allows for connecting over TCP, which is nice if you don't have one machine that's plugged into 1,000 devices, that you can just have the devices on Ethernet and connect to them over the network. And unfortunately though, ADB has some cases where if a board is rebooted or if a board somehow loses its network connection, when that TCP connection is terminated, ADB won't kind of restart it. And so whereas with USB, if you reboot a device, it goes down, it comes back up, tests can continue. And so there's some problems where we run into connection issues failing and then the device is just offline. There's also CTS, we've had some recent issues with CTS results. Basically the XML that's produced has some invalid characters in it, and so that causes rendering issues in the various browsers. But we work around that by filtering. And then the other issue is that you go through, you spend your 16 hours running it, but not all of the tests really apply to dev boards. We don't always have cameras, we don't have GPS, so there's you get basically hundreds or thousands of failures in the end results, and you have to kind of filter out which ones actually matter to the board or which ones don't. And so that's just rough to get through. As far as the other issues that we run into are stuff with infrastructure. So Lava is just complex. The managing of a lot of boards, the being able to automatically deploy and get the job scheduled runs into lots of quirks. Especially for someone who's starting out, Lava is not the easiest thing to ramp up on. We also have the different versions of Lava that we're transitioning between version 1 and version 2, and that's not kind of complete yet, so it can be nebulous on whether or not the issue is something that comes up on a Lava 1 job or a Lava 2 job. And then the results, if you're trying to just dive into the Lava web page and pull out results from a run that's happened, it's not easy to just get that. So a lot of work goes into that, aggregating the results into that QA page that we keep internally, and then filtering that into a PDF report. And so that was something that Milos and others have put a lot of effort in. And so it's one of those things where it's not easy to just kind of casually throw stuff in and get those results. Now, we've got a lot of workarounds that we use internally. One thing we did is we went out and talked to our members and said kind of which of the CTS tests are most valuable to you. And that way we were able to kind of collect a subset of the CTS tests that we run in a plan that we consider kind of more focused. And this pulls our run times down to kind of more reasonable times. For full CTS runs, we've also split the full CTS test plan into sub-plans. And this allows us to do some parallel execution so we can run some tests on this machine, some tests on that machine. This is sort of similar to the sharding that CTS does itself now. But I will talk a little bit more about that as we go along. We've also gone through in our own custom plans and cut out all the tests that cause the ADB failures, or the ADB TCP failures to happen so that we just kind of avoid them. And we also do the filtering on the XML results in order to avoid the rendering issues. And so these are all things that, it's necessary in order for us to churn these results out, but they're all sort of our own private hacks and workarounds. And we're not really sharing these widely. These aren't things that are, everyone's using. And more problematically is we're not really addressing the issue upstream. And so that's something I want to see about changing. Now, when we talk about LCR, this is kind of basically LCR is branched off of the latest AOSP tagged release. And so it's kind of considered a stable base that people can do some development on. And so basically it ends up being a branch. We get our board support added, do our testing and all of that, and that all happens off of this branch, and AOSP master is moving forward all that time. This has some limitations. Some of the aspects is that the number of engineers who are focused on LCR is limited, and so when bugs crop up, trying to dive in and fix things can be difficult, especially if it's not clear whether or not it's an AOSP issue or an issue with the device. We also have, since our testing is focused on the kind of this branch, we're not really looking that much at AOSP master with the testing. And so part of the thing here is that, while this testing does provide value to our members, it's not really affecting the larger ecosystem as much as I think that we could. That said, saying just go run AOSP master isn't always the best idea because the stability on AOSP master isn't consistent. We've had, a number of breaks just in the last month. The Bluetooth on HiKey has been broken for 3 weeks out of the last 4. So it's one of those things where that's not something you want to block folks who are doing development on. And then on the kernel side, it's hard for us to kind of push vendors to move to kind of the latest AOSP trees because they worry about the stability of the Android kernels in the early days. And part of the issue there is that the common kernels are kind of tested one step removed. And so they're always tested on a device, but the devices have their own patch stacks. And so common is just a small portion of that. And so because the devices don't run mainline kernels, it's very difficult to do just testing on common kernels by themselves. And so that means that we often see a lot of issues that are found in the common trees to only show up once enough devices are actually using those common trees, which is later in their lifetimes. So want to talk about some future directions that will hopefully try to remedy some of these things. So even though I think it's going to be hard, I think we should be focusing more on AOSP master. I think we can work more closely with Google, try to make sure that any of the issues that we run into with testing that we get fixed upstream. And then basically as we do our testing, as we find problems, if we're finding problems in AOSP master, we can, it's not just our own little fork that we have a problem with. We can engage folks at Google who might know the code better than we do. And so it kind of cuts down on kind of the debugging in the wilderness feeling that sometimes can happen. And overall, it's just the goal is to raise the bar a little bit and make AOSP master more stable, more testable. And so for this, I kind of want to get the initial efforts focusing on HiKey and QEMU and KVM targets. Part of the reason for this is that we've got to pick devices that are in AOSP, and AOSP has a somewhat limited set of devices. We could go and use some Nexus or Pixel phone devices for testing as well, but those are stuck on a fixed kernel version. And so by using HiKey and QEMU, we can move between kernel versions and be able to do a little more kernel-focused testing. There's also some interest on running AOSP under ARM64 KVM hosts, and that way we could do not just x86 testing in KVM, but that's something still to do. And so overall, the plan is to kind of move to a more collaborative and effort of testing and bug fixing. This is similar to kind of the upstream first effort that we do in the kernel community, where instead of waiting for a release to be made and then starting to do kind of the testing and productization, you jump in early, do a lot of testing as development's going on, kind of reining in the chaos as much as possible. And so that when that release is made, you have some assurance that it's more stable. We've started some of this effort already. We have high-key AOSP master builds going on regularly in Jenkins, pushing those out, trying to generate CTS results. At the moment, getting those automated CTS runs working regularly is requiring a little more hand-holding. It's not as automated as I'd like right now. So we don't yet have a point where I can just point to a public URL that shows what the current CTS results are for high-key. And so this is something we're working on right now, and hopefully we'll be able to show soon. Also want to try to increase the kernel-focused testing. So this is basically trying to get it so that we can validate the common kernels better. Some of the ideas here is basically working with Google to try to figure out what is kind of a more reduced set or test plan in CTS that is more kernel-focused, so things that aren't just stressing the JVM would be bid, or so we have a reasonable runtime to do this. Also want to look at integrating more community test suites to run inside the Android environment, like LTP, the K-self-test, XFS test, and possibly others. Now, Google already has these kind of interesting networking tests that they use, where they basically use UML, which is user mode Linux. And that's basically where you compile the kernel into a user space binary that then just runs on a machine. And so this is nice because you're able to very quickly do testing, because you don't have to boot up an emulated device, you don't have to deploy anything, it just it spins up really fast. But the downside with this is that it is very much kind of removed. So it's testing the very generic aspects of the kernel. And I think that it still has value to do that sort of testing on, running those same tests on the real hardware as well, so that we know that the network configuration for the devices are proper as expected. So once we have kind of this environment, this Android environment that we can do a lot of testing in, I think it's also important that we start moving to testing LTS and upstream kernels inside of this Android environment. And this, I think, is really valuable because the upstream community really doesn't have Android in mind when it's doing development. And so a lot of bad assumptions sneak in occasionally. Even just maybe last week or the week before, what I usually do during the merge window is I'm updating high-key every day to see kind of what new stuff is in and make sure that the patches still run. But turned on my machine, booted it up, and it just hung. And so basically something upstream had broken Android. And luckily it was only a day of Delta that I had to dissect down. And so that was fairly quick to be able to find the patch. And it was this very subtle SE Linux patch where it was just adding some new entries to a little table. And this might have taken me days to weeks to actually figure out what was wrong. But I didn't have to, because I just was able to raise the flag, send a mail to LKML, tell the maintainer, hey, you broke Android. And they immediately got it reverted and found a better solution for what they wanted to do that doesn't have the problem, and that got in before RC1. So it was having that fast feedback was really valuable, because it just reduces the amount of time that people have to scratch their head and try to understand code that they don't have expertise in. For speeding up CTS runs, as I mentioned before, running fewer tests is always an option. But there's also, CTS does support the sharding of test plans across a number of machines. And so this is very similar to the sub-plans that we use. The difference is that it's basically at a different level that the scheduling goes on. So rather than having Lava decide that these tests are going to run on this machine and these tests are going to run on this machine, the CTS runner will split up the tests depending on how many machines are connected at the time. And so I kind of think that we should try to converge possibly on the sharding method, just because I think it would be good to have everybody sort of using the same method where possible, and where the sharding method doesn't work for us, we might want to try to improve that upstream so that we're not just doing our own thing. Also want to try to work to get AOSP to run in Google Compute, and the idea there is that by being able to shard CTS, we could possibly just spin up a whole bunch of machines and cut down the CTS test time dramatically. So I've been looking a little bit at running AOSP on Google Compute. At the moment, you need one FS-tab change on top of the x86 engineering target, and that's been submitted. As far as kind of quirks, there's no graphics. There's not even pretend graphics like in most QEMU environments. So you have to basically enable a virtual frame buffer, make sure you're doing software rendering. And then another problem is that when you do an AOSP build, the objects that you get a couple of disk images, but none of those will just work for Google Compute. And so you need to assemble a boot disk. And so I've got a little script that I've posted there that basically takes the output. It takes a kernel and an or a RAM disk and a system image, and we'll build a disk image that contains the user data and cache and bootloader all installed. And so I was going to do a demo, but because we're so short on time, I'm not going to try to do that. Come check it out on Demo Friday. I'll have something set up. As far as the further efforts going on, going to work on integrating Google Compute with Lava. At the moment, I'm kicking these jobs off by hand, and so it'd be nice to have kind of automatic deployment going on through Lava. Want to try to continue pushing changes up to Google so that changes to the test plans that we're using, we can try to find some way that it can be more widely shared. And then also trying to collaborate with Google so that we can maybe get this Google Compute stuff working in AOSP, and so that can be more widely used, and it's not a bunch of tricks that we've got on a slide. And then also trying to resolve any sort of CTS failures that we see in AOSP master. Part of the issue is that when you do have tons of failures, people stop kind of understanding which ones they should care about. And so I want to make sure that when a failure happens, people know that there's a clear problem that they need to address. So I think that's it for discussion. I don't know what we've got for time. We're out of time, but 5 minutes maybe.
How hard will it to create something like, from your experience, something like CTS profile, height, for example?
I'm not sure yet. That's maybe.
For example, this is what you told, that
So
not all tests are relevant, but you will create a profile that for this board we run only this set of tests.
So we have the
another board.
focus test that we use. Youngquin, I don't know if you want to comment on that, as far as what's all in the focus test and what we expect to pass.
The focus test, we have the Android view, Android Bionic, and content test, something like that. Yeah.
But how hard is to create this profile for the specific board?
How hard? It's just some XML file we created manually, and then updated it to the .jar file, CTS trade fed jar file.
Yeah, so this is maybe an area where I'm not an expert. So it's one of those things where I think that we'd be very interested in trying to get maybe a special profile for Heike upstream if we can. If that's as far as where do we submit that, I'm not sure.
Perhaps one interesting thing also would be to see how difficult it is to update one profile that is already created based on CTS tests that get added. So creation could be a one-time job, yeah, sure, but as a new version of CTS comes, how do you make sure in some automated way you could add two profiles?
Yeah, I don't know if you're going to do it in an automated way.
or okay, not automated as much, but
You can run the full test, what failed you remove from profile.
But yeah, and at the moment, a lot of that, the QA report site, it logs failures, and so we're really looking at deltas. So like if things are increasing or not, there's not a lot of time spent on chasing down every issue. So I don't know. Yep. Yeah. Oh.
What kind of measures do you have to deal with upstream instability?
I'm sorry, so upstreaming stability?
Yeah, I mean the instability of the tip.
Oh, for AOSP master?
For AOSP master, yeah.
So I mean, I think it's one of those things where no one's committing stuff to AOSP intending to break stuff. Like, no, I don't think there's ever the point where it's like, oh, it's fine, the tree's broken, that's fine. I think it's more an issue of making sure that we're testing enough so that when something happens, we can be fast enough at responding to it that it's, people don't figure that it's the idea of reverting it and sorting it out in the longer term might be a better approach. At least that's the way that upstream kernel community tends to respond to it. You know, we don't have full control over AOSP, so it's going to be about internal policies. But I think if we are able to provide fast feedback, that helps at least. So.
Why don't you test on Linux next instead of version?
For me, it's just a matter of I like to have a small window of time that I have to do this work instead of all the time. So I probably should do more Linux Next testing with HiKey, but just personally, it's not something I've had enough bandwidth to do. So being able to keep it to 2 weeks for every 2 months or something like that's a lot easier.
Wouldn't it be bisecting one day versus
I'm sorry?
doing it daily? Wouldn't it be bisecting one day versus daily?
Bisecting one day versus daily? I don't know.
If you test right before the merge window of Linux Next, you can find the problem. And versus testing every day to see if there's a change.
Yeah, although having the everyday, if you find just a problem, then bisecting down through that can be, it's a big set. And so the nice part is that I know that on one day it worked, and the next day of the merge window it didn't work, and there's only so many merges that Linus took. And so I know it's in that set. And so it's a smaller set to look at. I don't know, that's, I admit that Linux Next would be great to do. It's just from my current situation, I have not had the bandwidth to do it.
And how do we make the CTS automatable easier? So at the moment it launches a shell which you have to like deal with somehow. So how do we try to convince Google to use some APIs to launch tests, get the results? And
so I don't know if anybody can speak to that. I suspect that it's one of those things where we need to start making proposals. And so we need to have an idea for what we'd like to see and seeing if we can push that up. And you know, everybody seems sort of, you know, agreeable to discuss ideas. You know, so it's one of those things where I don't think that anybody's going to just say no right off the bat. But you know, we got to get to the point where we're talking about specific ideas, I think.
But Google is supposed to make the CTS, those kind of tests, more automated, right?
Yeah, no, the problem is they are easily.
well, they are easily launched as a bulk, right? But then you cannot control. You don't know whether it crashed, whether it timed out. You just have to wait. And that's it, because it has its own shell. That's the problem. And there is no interaction when the tests are running.
When developer is working, like if I'm working on camera, then I will be interested on camera CTS tests. So I'll only enable camera tests and do my testing before I say my job is done. So I'm saying from Google perspective, what they do the developers do in general, and they don't run entire test suite every time, and it's maybe a validation team. Like once all the product is ready, then it gets to complete CTS tests. So.
That's not the point. The problem is that we run it locally, right? Yeah, and I'm saying about running remotely. So I just launch the test job and it runs. And I have no interaction with it. It can run on the other side of the world. So basically an API for this executor shell would be a great idea, because then I can like control what's happening and know what's happening in my test job. Right now I just launch it and wait and pray.
How do we make this infrastructure VTS ready?
No comment. Anything else? I think probably that's time. So, all right, well, thanks.